So we've got a question here where we've got a pulley system and it's on an inclined plane with a weight here which is 5 kilograms. And in here we've got some sort of crane system with two blocks, Q and R. Now the mass of P, Q and R is 5 kilo, 10 kilo and 5 kilo. So Q is 5 kilo, R is 10 kilo, P is 5 kilo. The incline is an angle of alpha and we're given that sine of alpha is 3/5. And 9.81 is our gravitational constant. What we want to try and work out here with this pulley system is to calculate the tension in the pulley system. So tension will be heading towards the pulley. So that's our pulley. Then we want to calculate the acceleration of the system. So that's what we need. Then we want the magnitude of the force exerted on block Q by R. So the force exerted on Q by R. So R is underneath. So there's something there to look at. And then the magnitude of the force exerted on the pulley by the string. So this time, instead of the tension, we want the force exerted on the pulley by the string. So the force here. So that's another thing there for us to look at. So first of all, part 1 and part 2, acceleration and tension, they're usually calculated by our Newton's law of motion. So we resolve for all of the forces at the two different points and then we set each one to mass times acceleration. So first of all, let's look at QR. So that looks pretty straightforward there because it's just vertically downwards. So at QR, it's going to be going downwards, so tension's going against the direction of travel. And then pushing against it's going to be the weight of this crane system here, which is Q and R, so that's 15 kilos, so that's plus 15g, and that will equal 15 times A. That's the mass, so 15 times A. We're going to assume that this crane system has a negligible weight, so we're not going to include it in our calculations. Then we want to work out what's going on at P. So at P, what's happening at P? Well, it's going in this direction, so T is going with the direction of travel. And we're going to set that to the mass times acceleration, which would be 5a. And then what about this force going downwards in this way along the plane? Well, as it's 5 kilos and it's going this way with this angle here, it will be minus 5g sine alpha. Okay, now we're given sine alpha. Sine alpha is 3/5, so we can plug that into there. So T minus 5g times 3/5. Well, 5 3s are 15 divided by 5 is 3. So we got T minus 3g equals 5a. So then we've got this equation here and this equation here. We can solve that by simultaneous equations. So if I put that one in there, and then as I've got plus t minus t, just going to simply add the two equations together. So then I'm going to get 20a minus 3g plus 15g is 12g. So then to get a on its own, I've lost tension, but I can plug my answer to a back in to find that. I've got a equals 12g divided by 20. So then A equals 12 times 9.81 divided by 20 gives me my acceleration. So I can plug that into my calculator and I should get approximately 5.886. So 5.886 meters per second squared. Okay, so that's the acceleration. Now I can simply calculate tension by plugging this into one of these. So as I've got T minus 3g is 5a, I'm going to use that. That looks pretty straightforward. So if I set T equal to 5a plus 3g, so then what's A? A is this, that's my 5.886. So T equals 5 times 5.886 plus 3 times g, which is 9.81. So then I can plug that into my calculator and I get 58.86 newtons. So that's the tension in the strings. So that concludes that part of our question. So now we want the magnitude of the force exerted on Q by R. So what's going on there? So the force of Q exerted on it by R. It seems a bit unlikely that anything's happening because R is below it. But what will be happening is that we'll have the weight of Q pushing down on R, and then the normal force from R pushing up against it. So what we'll have there, so if we go at Q, then what we will have is we'll have the weight of Q, 5G pushing down, minus the normal force at R. Normal force will be going in the perpendicular to the block, so we call that N. And so that's the forces, and we just set that to mass times acceleration. Well, the mass is 5, so that's going to equal 5A. So then we could set N equal to 5G minus 5A. Okay, so we know what G is and we know what A is. So we've got 5 times 9.81 minus 5 times 5.886. That equals our normal force. So then that will give us 19.62 newtons if you put that into our calculator carefully. So 19.62 newtons. So that's our first 3. And now we come to the last one. This time we want the magnitude of the forces exerted on the pulley by the strings. So this is not the tension in the strings, this is the force exerted on the pulley by the strings. So here we've got these tension in the strings going at an angle. So if I just draw a small diagram here, that's my pulley system, that's my strings. What I need to do is I need to resolve for my forces exactly down the centre. So I need to sort of bisect the whole thing. And now what I do is, if I just draw and make 2 right angled triangles here, so it must, as I'm resolving in this direction, so I'm going to call that R, I've got a right angled triangle there and there. This part of the triangles will be T, and as we want this here, we need to find what R is. So we need to work out what this angle is to find that first. Now we've got this system here in the pulley, which is alpha. So if I just draw that next to it, so if this is my alpha and that's a right angle, this angle at the top will be 90 minus alpha. Now I'm going to split that in half, in which case I'm going to have 90 minus alpha over 2. So if I split that in half, I'll have 90 minus alpha over 2. Okay, so now what is my R? So if that's my angle there that I'm interested in, that's the angle there and the angle there. For my R, I'm going to need cosine, and it's going to be of this angle. So here, let's just draw a line under that. So my R, force R, will be cosine of 90 minus alpha over 2. So cosine of 90 minus alpha over 2, and that's going to be multiplied by the tension. So T cosine 90 minus alpha over 2. So if I just do that in the step to show you how we got there, if I call that my angle, let's call it in this case phi. So I've got cosine of phi equals adjacent over hypotenuse, that's R over T. And then to solve for my R, just multiply both sides by T, then I get R equals T cosine phi. So that was why that would be there. And then that would be for one of my R's, and then I need the other force. So I need the one with coming from this side as well, and again that would also be cosine. So then I'll have cosine of this case phi equals R over T. So it's going to be the same angle. So I'm going to have to add T times cosine of 90 minus alpha over 2. So now we need to work out what alpha is. So I've got sine of alpha equals 3/5. So sine alpha equals 3/5. So therefore alpha equals the inverse sine of 3/5. So if I plug that into my calculator, I'm going to get approximately 36.87. But I need 90 minus alpha over 2. So that's going to give me approximately 26.7. So 90 minus alpha over 2 is approximately 26.57. So then if I plug that into my calculator, cosine of this angle times t, well t, what is t? T is 58.86. If I plug that into a calculator nice and carefully, I should get approximately 105.29 newtons. So that would be the force exerted on the pulley by the strings. That completes all of our questions. Okay.